bloody hell. We've started. Good evening, ladies and gentlemen, boys and girls. I wasn't paying attention then. I'm going to hand you straight over to Catz tonight because I can't even spell PCR, so I'm probably not the best one to explain what tonight's debate is about. So, Mr. Conspiracy Catz, over to you, sir.
Well. Tonight is more challenge to anybody out there who has got strange ideas about the tests about the reliability about the tests for the COVID virus. I've seen a lot of crazy claims in the past couple of days. So we brought somebody on who is a seasoned PCR veteran who knows inside out and can answer and help us debunk all the silly claims about the PCR test. And we'll talk about some of the antigen tests as well, and put to bed a lot of the crazy ideas that have been around. If there does happen to be anybody in the chat who doubts or supports any of these crazy claims or wants some explaining, then, maybe we'll bring you on later on in the second half of the stream. We can have a friendly and civil chat about it. But for now, I'm going to introduce you to our guest, and I'll let him introduce himself, actually. And then you can tell them as much or as little as you want us to know about you. But take it away. Just introduce yourself, sir.
Okay, hi guys. First of all, it's great to be part of the chat. I want to thank Creaky and Catz for bringing me on. My background in PCR in particular, I started doing a higher certificate in biochemistry in college, which required multiple semesters of like microbiology and different form of analytical sciences and stuff like that. After which I was given the opportunity to move into a degree of my choosing, and I chose biotechnology. Now, biotechnology, specifically this course that I did, required me to perform PCR tests, multiple PCR tests, virtually at least once a week, if not twice a week. So I am pretty familiar with the concept and with how it's done, with what goes into it, how the machine works. Hopefully I can answer any questions anyone might have regarding that, or at least give a description on PCR and how it's done, which should, as Catz said, put to bed some of the crazy claims out there that about PCR. So hopefully we'll kind of get some closure on that.
Brilliant. And I really, really thank you for being here. Honestly, I really, really do. And we're already getting a couple of questions in the chat. Burian has said the PCR test doesn't test for COVID-19, and we will get to all of that. And if you do have questions, please just keep tagging us in, and we will answer your questions and explain what sentences like that or statements like that mean. But for now, well, first of all, Creaky, have you seen anything in the chat? Is there anything you want to address, or? Oh, he's muted himself.
Yeah.
Or have I muted him?
No, I muted myself. I'm so good at this. I don't know why we don't get more viewers. Yeah, I'm basically gonna keep an eye on the side chat. Like I say, I just threw that up on the screen. Then the PCR test does not test for COVID-19. I'm sure if anybody wants to make any claims, that Paul will be more than happy to address them as we go through the stream, and I'll try and throw them up onto the screen as we see them. So,
okay. Well, what I'm going to do, if I can, Creaky, then I'm going to screen share. I've got just a school level PCR diagram, nothing too technical, something I'd use at school if I'm teaching it to the kids, which I'm going to put on the screen. So you should be able to see that, Paul. And then, do you mind just talking us through just what PCR is, so everybody who's watching can understand, like the misconceptions people might have had around it as we go forward?
Yeah. Sure, I'll do my best.
So share screen. I'm sharing screen. I'm sharing that one. So hopefully you should see it in a second.
Oh, there we go.
As if
there we go. I'll hand it over to you, mate.
Perfect. Okay, so I want to point out there, first of all, what you're looking at. So at the very top,
hover over what you want me to hover over.
Yeah, it's the very top left. We'll start with step one. So first of all, you have to understand that what goes into the PCR machine is kind of a cocktail of ingredients along with your sample DNA. So what you're looking at there is what the machine is doing with what you've already placed into the PCR tube, is what it's called. Now, I do want to point out there that you have double-stranded DNA, which is what typically you'd be working with. Basically, in your sample, you'd have what you have to do first of all is you have to kind of remove all of the excess stuff that you don't need. You have to isolate the DNA. Essentially, what you're going to be doing is you're looking for a single small piece of DNA that exists in a much larger amount of other DNA. So essentially, you're looking for a needle in a haystack. Now, the problem is you have to create the haystack first, and then you have the issue of determining whether there was a needle there in the first place. So basically, what you would do is you would use they're called primers. So see up there. So you actually have two different types of primers. There's what's called forward primers and reverse primers. Now, what you have to understand is when your sample goes in, the machine basically runs the temperature. It kind of facilitates the synthesis of the DNA. Like all the ingredients that are inside the actual tube, like there's basically kind of bases. It's called DNTP mix, and those bases are all the A's, G's, T's, and C's that make up DNA. But they're just kind of, I suppose, floating in suspension. They are your building blocks, so they're going to need to be put onto the DNA of choice. Now, what you also have in the tube is, like I said, the primers, and you also have polymerase. It's right there, DNA Taq polymerase. See where step 2 is? Yeah. That is another ingredient that's in there. And the nucleotides, actually, over on the right-hand side, that's the DNTP mix. Those are the kind of bases. So what you have is you have Taq being the actual worker that helps to kind of synthesize the DNA. You have the nucleotides, which are the building blocks. And then you have the DNA primers. Now, what the primers do is they find your specific segment of DNA. What they do is when you have double-stranded DNA, the heat opens it up kind of like a zip, essentially, which makes all the DNA that's, instead of being double-stranded, it becomes single-stranded. What the primers then do is they find the gene of choice. The forward primer will find one of those sections of DNA. So let's say the left strand for ease of kind of explanation. And that forward primer, normally about 20 or 30 bases, is specific to that section of it flanks your gene basically that you're looking for, your segment, your indicator, I suppose.
Can I emphasize that point? Sorry, Paul, for interrupting, but can I just ask you to emphasize that point? Because you said it's like 20 to 30 bases long. And so the primer is designed to sit on one side of the gene.
It is
20 to 30. Can you just emphasize how specific and that will be, and the chance of it fitting anywhere else?
Okay, I can. So let's assume that you're using, let's say you're using a 20 base pair sized primer, right? Now you have one side of the gene, and you need those 20 bases. You have 4 different building blocks of DNA, basically G, A, T, and C, like I said. And G and C connect to each other by hydrogen bonding. A and T connect to each other by hydrogen bonding. So if you have just a C and an A, you need a G and a T to actually attach to that. Now you need that all the way down 20 base pairs, and that's one primer. You have another primer flanking the other side of the gene. That can be 20 or 30 base pairs as well. So if you have, let's say, 20 on one side and 20 on the other side, the chances of just randomly getting a segment of DNA that matches that on either side of a gene is extremely rare. I mean, 1 in an octillion rare. It's crazy. Now, you have to also understand that when you're making that primer, you know your sequence. So you know, like I have, as I was explaining before this, I have went and I found the entire 30,000 genome sequence for SARS COVID-2. It's easy to find. Like it's not hidden information. And what they do is you basically there's an, how do I describe it? So you have there's a particular scientific principle called bioinformatics. Basically what you do is when you sequence something new, you kind of compare it to everything you already had on your database. So you would have databases with like thousands, millions and millions of genes from all different species. And when your organism is genome sequenced, you put it in there and you can see, oh, this is where it evolved from. Oh, this is how it's just as rare, like it can compared to this one, it's 80% similar or whatever. So you know which genes will not randomly appear. You'll know which ones are specific to, say, SARS-CoV-2. I think the gene in question, now there's a lot of different primers. I mean, different companies make different primers. And one in particular is a gene called RDRP. It's a RNA polymerase gene. And that is not, you're not going to find that really in eukaryotes. You're not going to find it in human DNA, particularly anyway. And the chances of you finding another virus that just so happen to have the exact same thing it's astronomically rare.
So in other words, the people who are claiming that any old bit of DNA can be amplified, and therefore the test shows you found some DNA and you create a positive that way, is wrong, because the chance of this working on DNA that isn't the viral DNA is, what would you say, like less than a millionth of the chance of winning the lottery? We're talking about those kind of odds.
Well, I have a comparison for you. I was looking at it last night, and if you consider that you've got roughly 4 to the power of 40, different combinations, you are actually you're a million times more likely to get struck by lightning. So that's just a base kind of random person getting struck by lightning a million times. That's the kind of chances you're looking at. Like, it's huge. Now,
and these people who claim that, oh, well, then you're saying there is a chance of there being a false positive. They've got to remember that this has to happen in every single person who is testing positive. You know what I mean?
Not just that, but if you look at the bottom left on what you shared there, repeat cycle 20 to 40 times. So even the chances, even if it happened randomly in one cycle, you're not going to get enough. It has to happen in all of those cycles. Now, to say that the PCR is 100% reliable is incorrect. I mean, you can have problems. The primers might accidentally cling to each other once or twice, like very rare. But anyone that runs PCR, anyone that runs it, runs it more than occasionally, will be able to spot that like a million miles away. When you have, and after that, you must bear in mind, after you've actually amplified your DNA, what we used to do is we had a gel. It's like an agarose gel, so it's like a porous gel that we would put our DNA with a dye into it, and we would run an electric current. Now, DNA is predominantly negatively charged because of its backbone. So what would happen is it would migrate through the gel, and it would stop at a certain point based on its size. So after we have actually successfully, replicated the DNA, we also get a piece that's the same size. So you must remember, even if a primer manages to actually attach to one side and miraculously manages to attach to another side, getting all the ones in between to be the same size is also adds an extra level of, probability, I suppose, to the test itself. It's just not true. I'm just going to outright say it, Yeah.
Well, I mean, I remember we had someone on here, and he was a nice guy, and I couldn't explain it anywhere near as well as you could, but I was trying to explain to him how specific these primers are and how it will be a case of, nobody would expect someone to win the lottery every day for 6 months, and that's the kind of odds you're talking about for this to go wrong in the way they're suggesting. And at the end of me explaining that, he literally just looked at me and said, "All I'm hearing is it's not 100% perfect," and that was it. That's all he wanted to hear.
Yeah. Well, that's science. I mean, science is never 100% perfect, but what we can do is we can eliminate all those other possibilities. We can bring it down to an extremely probable outcome. It's like when you find DNA at a crime scene and you wanted to, let's say, amplify that DNA to compare it to other samples. The chances of you getting someone that has the same DNA, it's never like you can't be 100% positive, but you can be so positive that without a shadow of a doubt,
Mm-hmm. So can I just see if I can run through in 15 seconds just to make sure that my explanation that I'm giving when I'm talking to other people is correct as a shortened version of what you said.
Yeah.
So it would be correct to say that we take the DNA sample, we heat it up to denature it. So the DNA that's a double helix here is going to split into 2 single strands. We then add that's mixed in with the primers and the nucleotides that you talked about. The primers then will find the bits of DNA we need, which we've got over here for this step. And then once they've found them, the Taq polymerase will turn these 2 single strands into basically 2 more double strands. So we've doubled the amount of DNA.
Yeah, it's an exponential increase. So
and then that keeps going on, so we get loads.
Yeah, so if you had a single one to begin with, you'd have 2 to the power of 30 after 30 cycles. That's a lot of DNA, you know. That's a huge number. Exponential increase is massive. So, but to begin with, you have to have it, you know. I mean, it has to be there.
And I think that's it. Yeah. So there's no way that you could end up with all that DNA if it hasn't come from the patient and the patient. Yeah.
No way. But you also have to remember. I mentioned at the start that that there's the actual PCR, the test that's done for SARS-CoV-2. That virus is RNA. So there's an extra step involved. You have to isolate all the RNA from the sample, not the DNA. You have to isolate just the RNA from the sample. Then what you do is you have to turn it into complementary DNA. You basically turn the single-stranded virus or section of DNA or whatever it's all going to be single-stranded. You have to turn it into a double strand, and then you have to run a PCR cycle on it. So when people claim, oh, it can pick up other DNA, well, I didn't isolate DNA to begin with. I isolated RNA, you know? So, like, it's just, I don't suppose it's as likely as the primers attaching to, I don't know, a different organelle in the cell. Like, it's bananas. We don't have that to begin with.
Well, I'm just hoping Creaky can screen share something for me, because it's interesting what you said there. I was actually speaking with I was arguing with a well-known moron, but it was offline, so I'll not mention it, about this. And they said to me that PCR only works for DNA, and therefore it's useless for testing for COVID because COVID's RNA.
No,
that was right.
Yeah, there's no that's not how it works at all. If you have RNA, you perform what's called RT-PCR. It's called reverse transcriptase PCR. I did it in college for my thesis. Basically, the idea is that after you isolate the RNA, like I said, you put it into an extra PCR cycle. I guess you run an extra PCR cycle on it. What that does is it turns it into DNA. Now we call it cDNA because it's complementary DNA. You essentially make that RNA double-stranded. Then the test works fine, just like every other test, every other PCR test.
So I've got on the screen, just screen sharing, because not everybody will remember from school the difference between RNA and DNA. You happy to run through that? I've got the.
Sure. So one of the big differences between RNA and DNA is that one of the bases in RNA is different. So in place of regular DNA, where you would have G, C, A, and T, that T is a U in RNA. So all the U's will connect to, basically, it's the kind of the polar opposite of the A's, essentially, in RNA. Now, RNA is single-stranded, which means it's in general, isolated RNA it's not quite as sturdy as double helical stranded DNA. I mean, DNA is much sturdier, essentially. Now, as you can see in the DNA there that you have, in between all of those base pairs, you have hydrogen bonds, and it is these hydrogen bonds are relatively easy to break when you add a heat to it. So you'd normally use about 94 to 95 degrees Celsius, and like I said, it would unzip the DNA and it will basically turn it into 2 single strands, which is kind of what we want to do, because if we have a single strand of RNA, we can attach other things onto it. You know, it's the basic premise of how a cell makes a protein. Basically, it needs a messenger RNA. So it needs just that one segment of single-stranded nucleic acid so that other things can attach to it and kind of, you know, that's how polymerase, it does its job. It attaches to it and then adds other bases to it. In the form of proteins, you know, it would be transfer RNA, and it would basically make it into nucleotides, or into amino acids. But the big change, the big difference is that one is single-stranded and one is double-stranded. Now, RNA viruses have to actually, basically, they have to use RNA polymerase to become, when they enter the cell, they become complementary DNA, much like in the PCR. So RNA is, it would actually need a gene to do that on the actual genome. And we kind of use that to our advantage when we're performing some form of test, because eukaryotic cells won't need to do that. Like we can make messenger RNA, but we don't need that messenger RNA to become DNA. Like that's not how it works. Messenger RNA makes proteins, and that's what they do.
That's brilliant. So hopefully anyone watching who's questioned like the specificity, is that a word? Specific? What's the word? What am I looking for?
Specificity is the best word for it. Yeah. It's like I said, it's pretty specific, and different companies will be making different primers. So I mean, ideally, you'll be looking for one, like the bigger the primer in sequence size, the more legitimate, I guess it is, the less chance you'll have of it just randomly appearing. And I also want to point out that the gold standard for COVID at the moment is the combination of a PCR test and a rapid antigen test. I mean, it's basically making doubly absolute sure. Yeah. So when people say that you can, the PCR test doesn't test for COVID. Well, it tests for the virus that actually causes COVID, and it tests for that pretty well if it exists in your, if it's in the sample, and then the rapid antigen test kind of just extra positivity.
So that's a brilliant rundown of what PCR is and how unlikely it is. I mean, it's so unlikely, it's impossible that you're going to make the kind of mistakes that they're claiming you make. Claims that they are suggesting in a minute, and see what you think of them. We'll have a chat.
Sure.
Creaky, has there been anything in the chat on that question?
The side chat is a hotbed of activity, and it seems we have another expert in our midst. Berrien. Mate, I have invited you 4 times already. You just send us an email, agree-to-disagree-debates@gmail.com, and I will send you a join-in link straight away. If you were so sure that everything Paul is saying is wrong, we would love for you to come on the show right now and discuss it with Paul. You're very, very welcome, mate. Apart from that, stop asking the same questions in the side chat over and over again, because it's getting a little bit childish. So unless you come on, stop asking the same questions repeatedly.
What are those questions, Creaky? We'll see. Paul can.
He's asking things like, can anyone prove that COVID-19 has been isolated? He's saying that all Paul is doing is using ad homs. He's asking people to prove it, but obviously
Can I point out something about the isolation of COVID? First of all, we isolate the virus. COVID is kind of the symptoms that the virus causes. Now, I want to point out that no work is going to be done on the virus without isolating it first. And when you're talking about whether we have isolated and how quickly we've done it, the first isolated COVID sample was on January 7th, 2020. I mean, like, the first case was in December. That's fast, And not only that, but this is part of the reason why the vaccine is done so quickly, because we can isolate them. I mean, I don't understand why people can kind of ask, like, say that we've never isolated. Like, I actually can screen share right now the entire genome sequence, 30,000 base pairs. Who's going to make that up? Like, who's going to sit down, write out 30,000 bases, and have every expert slumped thinking, oh, look, this is, I put this into the database and all these genes fit and it works kind of, we can see the evolution of the virus. I'll be honest with you, if someone could fake it, that would be much more impressive.
You say you've got the paper with the, like, are we happy to screen share that, just to show the isolation? Is that something we can do, Creaky? Yeah.
You need to again. Yeah, I know. Sorry, you should have an option there, Paul, to share your screen if you want to do that now, and then select what it is you want to share. As soon as I see it appear, I'll pop it up on the screen for you.
Sure.
So while Paul's doing that, so Berrien, this is the answer to your question. Has it been isolated? Paul will show you now the entire genome sequence of that virus. And that ends the question. If you just keep asking from that point, has it been isolated? You're clearly not listening to what he's about to tell you.
Okay, so I should have it here. Right, so what I have here is essentially the entire, you can see on the very, like it says under FASTA, it's Severe Acute Respiratory Syndrome, Coronavirus 2 Isolate, Wuhan, Complete Genome. It is, and I'm going to scroll down on it, 30,000 base pairs. Very easy to get. There's a website called the National Center for Biotechnology Information, and they share all this data. And this, I mean, you're not going to get that without isolating it. Like, you have to isolate it, then you genome sequence. It's how we do it with every virus. And that is, honest. I mean, that's pretty much as much proof as you're going to get.
Yeah, that is what the virus looks like, isn't it? That is it. You know, that's better than having it on a picture, isn't it? That is the virus.
That's it. It's just a huge line of information that we can't possibly get without isolating the virus. I mean, how are you going to get that? You're gonna go in and take out a piece of someone's, you know, throat swab and then guess? Like, you isolate the virus, you sequence the virus, the genome, and you have it. And the isolation step, like I said, was done in the first week of January, and it was shared globally on the 12th of January. And the first case in USA, the first actual case of someone in the US lab isolating it, was February. It's really quick.
Well, something else Berrien has just asked that I've just noticed was, he said, "Oh, that paper hasn't satisfied Koch's postulates." Now, I'm not having a go at Berrien. I'm really not. What I believe has happened here, you get people like Andrew Kaufman and Kate Shimarani, and they can speak quite articulately, yet they are thick as pig shit. I'm just going to say it. They haven't got a clue what they're talking about. And they're using terms that might sound a little bit fancy, and I think you're caught up in that, and I think you buy into it because they're really articulate and you believe it. I'm just going to ask you now just to listen to what Paul says in the next few minutes about Koch's postulates and about why strict Koch's postulates will never apply to a virus, and what we do to get around it. And we'll have a little bit of a chat about Kaufman, who obviously you've been listening to. So go on, Paul. Can we put it on the screen as well, Creaky?
Yeah.
Okay,
there we go. So
I want to point out, first of all, with Koch's postulates there, I want to point out the year that's beside that. As you can see, it's not new, you know? I mean, the 4 postulates there, the microorganism has to be found in a sick person, and you have to find a causative organism. Then you have to isolate it and grow it in pure culture. Then you have to reproduce the same disease in another host, and you have to re-isolate the microorganism from that host. Now, that sounds, when you just describe it like that, like, yeah, that's easy, that makes sense. But this was written well before we even knew viruses existed. And, like, I mean, one of my favorite games to play, when someone does say, "Oh, the virus doesn't meet Koch's postulates," I like to list all the things that Koch's postulates is older than, which, you know, it would include stuff like the entire sport of basketball, or back when Koch postulates was trending, so were Jack the Ripper murders. It's old. It's crazy. Like, so first of all, when Robert Koch wrote it, I want to point. Yeah, that's good. I want to point out that that initially he wanted it. It was to show that tuberculosis and cholera were caused by, you know, organisms that he could then prove fit Koch's postulates and prove that these are the organisms that cause it. But then he noticed that Vibrio cholera, the bacteria that causes cholera, can be found in healthy people. Well, that pretty much is, you know, that doesn't fit Koch's postulates. You know, that's 1 out of 2. And it's already failed. I want to point out that leprosy, as well, at the time, couldn't be isolated in pure culture or grown in pure culture. So that's another one. And leprosy exists. I think we know all about that. So when viruses came to be a thing, I think most people anyway that would know about Koch's postulates would know it as very good up to a certain point, and then we need to alter it to kind of, I suppose, keep up with what we know. Now, the Rivers criteria there. I want to point out that that's also 1937. That is not new either, you know. So with the kind of, I suppose, the advent of biotechnology and all the crazy things we can do with DNA, particularly genome sequencing and isolating of viruses and stuff, we need to actually alter the criteria as we go along. That's how science works. It doesn't fit one thing that was written hundreds of years ago and then has to fit that. We have to alter what we knew compared to what we know. And what you were saying, that Dr. Kaufman said, was that Rivers criteria hasn't been met for SARS. I actually have a paper where the SARS in 2003 was actually did meet the Rivers criteria as amended by the team that did it. So it very much has been, fits all the criteria that we know now, that we've amended now for all the new viruses that we didn't know about back then.
I think the problem with Kaufman and why he's banging that drum about it doesn't fit Rivers criteria or no virus ever has, etc., is because when you look at that Rivers criteria, and like you said, it was 1937 they came up with it, which was pre our genetic testing and our genetic analysis stuff.
Yeah.
Because genetic testing was used to find the virus rather than the old-fashioned, less effective methods. He said, well, PCR testing wasn't in Rivers criteria, therefore, it's just the dumbest thing, isn't it?
It's crazy. It's like if I'm watching a silent movie on TV, my TV has color, therefore the silent movie doesn't exist. It's that came out beforehand, but you know what? We kind of update what we have, and everything it all works fine.
That's brilliant. Now, Creaky, sorry, I'm just trying to keep an eye on the chat. Are there any other questions?
Only from Barian, who I've got our email open. We've still not received an email, so I don't know if he's misspelled it or something. Or
I've got a very strong feeling I know who that is. Anyway, I'll tell you later on. I've got a very strong feeling, and that might be somebody I've been speaking to recently who is coming back for seconds after getting a spanking offline not so long ago. But I'll mention that to you offline. Okay. So, because they're coming out with all the same nonsense.
Yeah.
So, in that case, then, there are some kind of just ridiculous claims I'm going to put to you. And these are claims that, I've pulled screenshots from Twitter, but they're all over the internet. The ones I share with you, I'll just bring some up on screen, and you can tell me what you think about them.
Go for it.
I'll share screen. I'll try not to show me holiday snaps, although I was looking funky in my Speedos. Smuggling peacocks. Now.
Whoop. Oh, wait.
Well, how do we do that?
I don't know.
So, there we go. So, false. In fact, I've got a fantastic paper that was. I'll show you the two. Then I'll hear what you've got to say. Then I'll show you the paper. So two tweets here, both saying that PCR tests just give ridiculous, 98% false positive. This one, 100% false positive. What are your thoughts on that?
Oh yeah, we're all lying. I want to address first of all the 98% false positive. I think I know where that's coming from. So it's good because this connects to what you have up on the screen now about Cambridge University. So before the rapid antigen test came out, the PCR test was, of course, alone the gold standard for determining, whether someone had COVID or not. Now, Cambridge Uni actually they employed a kind of a new rule where every week anyone that lived in university housing had to get tested for COVID, whether they showed symptoms or not. So basically, there was 9,000 students to test. That's a lot of PCR tests. So they came up with a system called sample pooling. So let's say, for example, let's say you had 5 people living in the one house. Okay, they're all students. They're all beside each other. So if one of them has it, there is a chance that they'll all get it. What they did was anyone in that sample would all get their samples pooled together in the same PCR test. Now, the reason they would do this is because if that test came back negative, well, then they don't have to do any more tests on that pool, because what they've done is they've turned 5 PCR tests into 1. Now, if it came back positive, 1 or more in that pool has the virus. Now, initially, people thought that this meant if one person has the virus in that pool, then the other 4 are false positives. That's not true. It might seem that way, but what happens then is you retest all of that positive sample pool to basically narrow down which one has it. And what they ended up doing was they turned 9,000 tests into under 2,000, which is quite a big deal. It saves a lot of time, money, and resources. And I think that's a huge part of where the high level of false positives comes from, because technically if you're testing a sample pool of 5 or 6 sample pools, and each of those pools have 10 people, then you've got 50 or 60 people, but you might only get 5 or 6 positives. All the others aren't false positives. They just have to determine which ones are positive in that. And the 100% false positive result that's actually, I read up on that. That's just someone misinterpreting the data.
Well, we didn't talk about the Cambridge test before this, did we?
No.
We didn't talk about that because this guy here on Twitter, he had a link on his tweet which took us to a paper from Cambridge University, and these are the results that you were talking about. These are the pool results. So 10 people tested positive. Not everybody. I mean, just look at that.
There you go. But look at the total pool. It's under 2,000. Like I said, there's 9,000 students in Cambridge Uni that were tested every week. So they turned that into less than 2,000 to do much less tests. And it, like I said, it saves time, money, and resources. But that's where all those false positives are coming from, because they assume then that, the 10 people, they all tested positive, but only 9 people didn't have it. So that's 90% false positives. That's not true at all. It's just the way they pool the samples together.
Yeah, you can read data sort of any way you want, and that they would. I think what they're trying to say is here, everybody that was positive wasn't positive, and that's what they're trying to say, or almost everybody was. So it was a 90% false positive. Well, that's ridiculous. We can see here that out of 1,937 people tested, 10 tested positive, and that was a pool, like you say. So most of them won't be positive.
And 1,937. That's not even people. That's the final pool results. So that's 9,000 people. That's not 1,900. So that's a lot more people. So you're going to have like if you only have, let's say, 10 people in the university with that will test positive, it's just really bad, I suppose. Just a waste to do 9,000 separate PCR tests. You got to find a way to make it easier, and that's what they did.
What bothers me, though, is this guy here, checked out his Twitter feed. I've blanked everybody's names out last minute, but this guy here, his Twitter feed is full of stuff like this. But he's clearly not read, or if he has read, he hasn't understood in the least what he's linked everybody to. Because what he's linked everybody to literally says exactly the opposite to what he's representing it as in his tweet, which, if Berrien is still in the chat, this is the kind of crap you're being fed, and falling for, unfortunately.
The thing you have to understand is, like, I suppose the fault is not with, like, if you're going to read something like that, like if you're going to read data like that and misinterpret it, and people do that. I mean, people that are well versed you can make mistakes, But if you're going to misinterpret data, you then can't use buzzwords to describe it to everyone else when they might not even just look at the data. They might think, oh wow, you must be telling the truth. You look at this stuff all the time. I think what we have here is just, like I said, misinterpreting data, which is very dangerous in particularly this day and age, with COVID. Like, we need to know, and people need to know that they're safe and that the testing is done correctly.
Absolutely. Creaky, is anything else in the chat bobbed in, or? Oh, he's muted again.
And I had my finger on the button. I'm just going to stop muting myself. So, what was the question?
I don't know now.
Sorry. No, I don't either. We seem to have lost our friend Berrien or Berrien or whatever the hell his name was. So I don't think we're going to get anybody on for you to talk to, Paul, unfortunately.
That's okay. I'm nervous enough as it is. Don't worry about it.
Me.
I also want to point out another thing. It's another, I suppose, thing, I've been seeing up a lot, which is the inventor of PCR, Carrie Mullins.
Oh, that's the next one. Let me screen share the tweets while you're talking.
Okay.
Yeah, in fact, I'll just read these tweets and then pass it over to you, because a lot of people have said Carrie Mullins said it wasn't a diagnostic test, or you could find whatever you were looking for with it. There's two there. There's another tweet here. We've got to stop using PCR as a diagnostic test, etc. And people are massively misinterpreting the role of PCR, and aren't they? So I'll stop sharing that and just let you talk about it.
Yeah. Okay. So I want to point out the context of what Carrie Mullins, Dr. Mullins, said in that if it's done well, you can find anything in the body. Well, if I have a target for what I'm looking for, and I do it well, and it's in the body, I will find it. Not I will find anything at all randomly. That's just not at all what he meant. It was basically that if you're looking for a specific segment of DNA, you will find it, particularly if you can actually, target it. And bear in mind, he said this 27 years ago. We've got much better primers now. Like, all the information, all the stuff we learn, and like in particular, like all the stuff we know about things like this, they get better and better and better each year. So like you can't use a quote from someone in the early 90s, misinterpret a quote and say, well, you know what, that's just life. That's it, how it is now. We can't make this any better. It's just not true. And I've also heard people say that Carrie Mullen specifically said that the PCR test can't test for COVID. Like, it's not a good thing for COVID. He died in August 2019, before the first case of COVID was ever actually recorded. So this is, again, people just kind of looking at it like an internet Chinese whisper and thinking, oh, I read something online that said that the guy said, yeah, it was specific for COVID. That way that people just kind of get the information wrong and share it like that. And it kind of mutates over time to become something it was never meant to be.
I've seen a quote banded around. I couldn't find one. I was a bit last minute with this PowerPoint. I couldn't quite find it on the internet, but somebody's saying something like, Carrie Mullis said it was a quantitative, not a qualitative test, and therefore can't be used for diagnosis. But in my opinion, I mean, would I be right that means, like, if I've got a broken leg and somebody gives me a test for COVID, then common sense would say that my leg isn't broken because I've got COVID. Is that what it means when you're talking about diagnostic, or did it mean something else?
Sorry, say that again.
So people are saying it can't be used as a diagnostic tool. So essentially, I always interpreted that to be, if I had something wrong with me, like I've broken my leg, but at the same time I tested positive for COVID, if I went to the doctor wouldn't say, oh, I know what's wrong with your leg, it's COVID. He'd have more common sense and he'd apply it.
Of course. Yeah. Of course. Like, and you must also remember, even if it were a quantitative test, and like, real-time PCR uses these fluorescent dyes. Essentially, what you do is, rather than having to take the sample after all the cycles are done, you can actively see like the actual, that your DNA or your target DNA is getting amplified, because the machine picks up the dye that's attached to a marker in the primer and is released when the primer has done its job. I want to point out that if you don't do that and you just amplify your DNA, then when you run it on a gel, all you have is a band of DNA of the size you're looking for. That's about as qualitative as it gets, Like, PCR isn't a one-trick pony. Like, you can do multiple things with it, and in that case, you can absolutely run it as a qualitative experiment to find a specific section of DNA. Take like I said when I said a needle in a haystack. Well, the needle's there. Yeah. I make millions of clones of it, but I can't do that if it's not in the DNA, and that's qualitative. Qualitative, yeah.
Yeah, you can't. Yeah, if it's there, you will find it. But if it's not there, it's not going to suddenly create.
What am I going to do? I get nothing. And like I said, I run PCR many times, and I don't always get something. You can tell after you do it. You run it on the gel, and you're like, oh, look at that. Look, it's totally blank. Like that happens, and you take that as my primers didn't attach to something because they didn't find anything. Simple, yeah.
Creaky, have we got anything in the chat? Anybody correcting us?
Somebody just said, where was it? It was, there we are. It's coming on the screen now. Truth nerd.
I think he's, is that someone tagging Adrian Clark in?
Not, yeah, I think, I'm not sure.
Because Adrian's quite sensible. I think he's having a laugh there. He's quite a sensible poster, is Adrian usually. Phlogiston theory and luminescence. Yeah, I think he's having a joke with that, which is...
Yeah. I don't think the PCR picks up the ether. I think that's kind of beyond its capabilities. It's a little bit more simple than that, But like I said, I want to point out that most of the time the technician that's running the PCR, like they don't make, like I said, they don't make the primers. They didn't make the sample. They isolate the DNA, and they make the master mix, which has all the ingredients that will do their thing, and then machine facilitates the temperature that allows for synthesis of DNA. It's that simple. The technician will simply run the machine, and if they know what's in there and they've done it right, that's just all it does. Like if people can take away anything from this, I want to point out that it seems quite complicated, but it is simple. It works, and the reason we use it all the time is that it works. And PCR didn't just pop up because COVID was here. It was here long before.
So, I remember I said to you offline, I did a biology degree, and we obviously did like genetics and microbiology units in that. And it's a long time ago, and I can't remember any of the specifics about how I did it. But, we did a PCR once over 20 years ago, and it was, in what massively wide use then. It's something that's not just popped along to teach us all about COVID, is it?
No, not at all. Like so, before PCR was around, bear in mind PCR take 2 hours, something like that, and then you got to run your gel. And for a lot of people, that's a long time. Well, before that, it was like 2-3 days. It was much harder to try and amplify DNA. PCR came along and just like, what you tell me? I just have to pop it into a machine and like an oven, ping, it's done. That's great, but that's why Dr. Mullins won the Nobel Prize, because he made things a lot easier for everyone after that. And I also want to point out it's unusual that the conspiracy behind how PCR is just it's not effective and it doesn't work as well. The conspiracy is very new. Like the PCR, like you said, has been around a long time. So where was everyone then?
Well, that's it. All these people who are coming out with, PCR doesn't work, viruses aren't real, viruses are exosomes, masks cause breathing difficulties and do more harm than good. Like I say, where were they 2 years ago? Where were they campaigning for the rights of nurses and doctors who've got to wear PPE, all day, or welders who've got to wear masks on, or people who work with microchips who can't cough out onto the tiny little transistors that they're making? They had to wear masks. Where were they defending them then? Where were all the all the people dying from mask-related issues?
Cats, it's because they didn't have to wear masks.
Exactly.
That's exactly. All it is. That's all it is. It's like, you're telling me I have to wear it? Well, I don't think it works.
Yes.
It does. That's not much else you can say about that. If the masks, social distancing, and avoiding contact, and good hand hygiene, if you do that, you get less cases of virtually any respiratory disease.
Yeah, definitely. You think about what our parents and grandparents, or my grandparents would have at that age would have gone through in their own time when you got the war and people going out fighting, and what everybody had to do, together to survive. And then you compare that with today's generation that they fought for, and they're running around like little kids because someone's asked them to wear a mask for 5 minutes when they're in a shop.
Exactly.
They'd be disgusted.
It's just when you can see people that I don't want to sound bad, but like if you've got someone that hasn't been oppressed, something like this feels like oppression to them. And I get it. You don't want people to tell you what to do, but I saw a news reporter. This is at the start of the year when all this started, that they were walking to get like a haircut or something, and they were saying that my hairdresser will get in trouble. This is like Nazi Germany. I'm like, no, it's not. Read a book about Nazi Germany, that's the thing. People are like, how dare people tell me what to do? It shouldn't have to. It's good for everyone. You help everyone. You help everyone. That it's a good thing to do. I don't see why people can't be more. I don't know. More on the team.
Can I ask you something which
what do you reckon, Creaky?
Be controversial?
Mm-hmm.
Do you think there's any genuine grounds for people to be exempt from wearing masks?
That's a really good question, actually, because I have a family member, quite a close family member, who has really bad breathing difficulties. They have had chronic asthma their whole life, and it's very serious. And I'm not going to lie, a mask can actually, it can bring on the kind of the offset of an asthma attack. But in that instance where someone should be exempt from wearing a mask, I would simply say that those people have to be more careful. At the very least, they shouldn't be in a position where they need to wear a mask as much. You know, like if you have no one to help you, you need to get help. You need to get people to go buy your groceries, and you need to stay indoors. Like, you shouldn't have to wear a mask in your own home, but like you can do things to avoid wearing it, you know. But yeah, it's extra effort.
Yeah. Because, you know, I had an instance today where I went to a local shop and there was a guy in there with one of these big stupid badges, or I haven't got to wear a mask because I'm special, and he was buying fags.
Yeah,
So,
I haven't seen that
you
over here.
dickhead. You know, I can't stand it. My dad, right? My dad's got COPD, emphysema, and he's had COVID.
Wow.
And so is my mother. They're both just getting over it. Now, you know, my dad doesn't go out a lot, but when he does, he's been wearing a mask just in case anyway. And I know then there are some people that will say, well, that proves masks don't work. No, it doesn't.
Okay,
it does
so
not prove masks do not work.
So there's alternative to masks as well, face shields.
Yeah,
you know, I mean, it's not that you have to wear, like, this is the only thing that works. There are alternatives that even people that say they don't have to wear a mask can wear, and I don't see any reason why they shouldn't have. You know, you can't wear a face shield. I mean, you should want to. You know,
yeah.
More along, like, it's not just, you also need to get the, like, you need to get the, you know, you need to be able to kind of to go out and do that little bit extra, like I said.
Yeah, we've just had I think it's a good question anyway. Can we ask you what false negative rates and false positive rates are? Because I was under the understanding that you could only have a false positive.
Okay, so a false negative, you can get a false negative, and like I said, there is problems with PCR. It's not 100%. One of the issues is, like, the primer. You know, like, if the primer is not done correctly, well, you know, it's not going to attach. And people can use, like, here's a good example. If someone, RNA virus, so if you're trying to test for it, you need to keep your RNA on ice, and then we're talking like minus 80 degrees. Like, it's really, you gotta, it's very, very, very fragile. So if it's improperly handled, you could destroy the RNA and not even know it. And then you could have the perfect primer, you could have the perfect cycle set up, and nothing comes up. And you might think, oh wow, you know, there's no COVID. There's a lot of factors involved. If it's all done right, there really won't be many false positives and negatives. Like I said, sometimes primers can attach to each other, very rare. But I mean, our lecturers, for example, the doctors that work in our college would point it out immediately and say, hey, look at that. That's what we call a primer dimer, and like, it sticks out like a sore thumb, you know. So to get a specific false negative and false positive when everything's done right and it's not immediately obvious to all of the experts involved, there really isn't many rates to talk about. It's so extremely rare.
Yeah. Because, you know, that what I just said, that came about when both my parents tested positive for it, and, you know, obviously because of my dad's COPD, my mother was very worried. Plus, they're both in their mid-70s, and she rang her GP, and the GP assured her that you could not get a false positive. So, you know,
that's what I'm saying. I mean, if it's done right, you're not gonna.
You shouldn't be able to.
You shouldn't. You really shouldn't. I mean, there's another issue involved if you do.
Yeah, nobody is perfect, and no method of testing for anything is perfect either.
Human error will be the biggest problem. Like I said, if in some countries fruit can test positive, that's not a flaw of the PCR. That is a flaw of the people that ran the PCR.
Well, the next thing I've got for you, actually, that's a good link onto that, and we spoke about this briefly offline. It's not PCR related. I'll just bring this up on screen if I can, Creaky. Sure. And that is this here that happened in the Australian Parliament. Somebody using an antigen test. Because this, when I first saw this, and I thought, oh, this was actually done in the Australian Parliament. I thought it was a joke, and then when I read about it, it genuinely was done in the Australian Parliament. generally came back positive, and I thought, oh, what? I wonder what's going on there. So, but well, I'll let you explain what happened, and I'll see if I can show the slides that explain it.
Yeah. Okay, so this was, like you said, it's not PCR related. This was what's called the rapid antigen test. It's an assay where you use an antibody, like a monoclonal antibody, that will attach to the, let's say, the outside spike protein of the coronavirus. So if it's there, it will attach to that, and then there you go. Then what you do is you'll add another antibody, but one that actually has a chemical marker on it. So then when you add the second chemical to it, you will get a color change that indicates, this second antibody is not going to actually connect to the antigen without the antigen being there. So, and also there's a lot of wash steps involved. So the test itself it's really good. Now, the Coca-Cola tested positive, which kind of made everyone go like, what? That's crazy. The test wasn't done right. There was no buffer added to it. Basically, there's a buffer. It keeps the pH at a constant level, and it protects the antibodies that are involved in it. So when the buffer wasn't added, the antibodies got destroyed during the test, and there was a false positive came up, which this was repeated. Actually, it's good. I can't remember the name of the lab, the lab technicians that did it, but they saw this test on YouTube, and what they did was they, as far as I know anyway, they repeated the test, doing it themselves, compared it step by step to what was done. You can see where the mistake was made, and Coca-Cola came back negative. So again, human error, So
essentially, just for those that can't remember what antibodies and antigens are, so the antigen is basically, we're going to consider that the outside of the virus.
Yes, that would be, in most cases, obviously, the virus has a spike protein. It's perfect for us to kind of, we can attach stuff to that. So monoclonal antibody technology involves making an antibody specific to that antigen. It is extremely specific. You will not get it to attach to any other random antigen. It is designed for that antigen. Now, the coronavirus spike protein isn't just randomly popping up in other viral species or the other in bacteria or in eukaryotes. It is for this specific SARS-CoV-2 virus. So, if the antigen attaches to the antibody is there. Another antibody attaches to it, you get a positive result. There you go. It is again really, really, really difficult to do incorrectly, and if you do it correctly, it is really difficult to get false results.
And because he didn't put the buffer in, the pH wasn't kept under check, and that destroyed the antibodies, leading everyone to think that.
I read up on it briefly, and essentially without the buffer, it caused some kind of, there was like a chemical problem in it. I don't know the exact specifics, but the not putting that buffer in is what destroyed the test. And you're going to get, you're going to get trouble. And when it was repeated, and that's science, we repeat things and we repeat them again and again. And every time we do a test, we do it in triplicate, if we can. So when something comes up positive when it shouldn't, we look into it. It was looked into, and we know the problem.
Brilliant. Have there been any questions, Creaky? Or
question from the side chat. I have to ask this question because of who it is. Dildo Baggins wants to know what Paul's credentials are because he missed the beginning of the stream. Okay,
so at the beginning of the stream, I said that I have a higher certificate in biochemistry, which initially started off as I was a returned student into college, and I took to say sabbatical would be one way of putting it, but I went back to college and I completed a higher certificate, which actually gave me semesters in microbiology, in gene technology, in analytical sciences, and then I was given the opportunity to do a degree. I completed a bachelor's degree in biotechnology. My choices were biotechnology, pharmaceutical science, or forensic toxicology. When I did that, I did forensic science, I did molecular biology, I did genetics, and then I completed the honors degree, which involved obviously a thesis and my own personal experiments to be done. And over the course of that, I did 3 years worth of PCR experiments. So I use it very frequently, and a huge part of it is having people there that knew what was going on. Having it perfectly described to you, so you're not just doing it as part of a job. You're doing all of these experiments to kind of explore all of the aspects of PCR, and that's what we did.
So hands-on,
really hands-on.
PCR.
The amount of experiments we did was there was a lot. There was a lot of cloning involved. It's biotechnology, so we had to know the ins and outs of viral plasmids, how to actually clone plasmid DNA into other into other microbes like E. coli and stuff like that, and be able to run selective marker experiments. And there was obviously more to that. Like I said, there's a lot of not at all. It's just I did it recently. Don't worry about it. But yeah, that's my credentials.
Cool.
So as somebody who's so closely involved in what's going on now with the testing and the methods used to test and everything, how does it make you feel? And I don't mean, does it make you want to cry? What are your thoughts when you see these people who say that the virus isn't real and that the testing doesn't work? And, as somebody from within the professions that are directly involved, how does that make you, what thoughts come to mind when you see this sort of thing?
Now, obviously, I'm going to get a lot of this online. The people that I know personally, I much prefer that because I can sit down, I can converse with them, and I can describe, here is exactly why this is wrong, But online, people don't want to hear it, and it is obviously upsetting when someone, say, posts a tweet about a specific piece of misinformation, and then there's a slew of comments of people agreeing with them, and that agreement kind of, I suppose, gives them the impression that they're correct about stuff. And we also, bear in mind, we live in the age where, you can get anything online. You can get any form of information online, and like I said, people do their own research. Doing your own research is hard. You have to find heavily referenced information, and to be able to read the scientific papers, they're not written for laymen. They are very difficult to understand. So it annoys me when people are able to find someone that explains incorrect information to them simply, because then they have this Dunning-Kruger, and it's a problem.
And therein lies the issue, doesn't it? Because what you've just described there is the problem with everybody that buys into any conspiracy, whether it's around the shape of the earth, the sorts of things Catz and I deal with. I don't understand it, therefore it's wrong.
Or I don't understand it. If someone that they think, this person knows what he's talking about, and he said this, therefore it must be true. An example, like you said, Catz, earlier, Dr. Andrew Kaufman. Dr. Andrew Kaufman, really?
That's psychiatry, I think.
Yeah, but psychiatry, but not everyone would know that. Not everyone would research that, and they'll look into it and say, this doctor is telling me that it's COVID-19 because there were 18 more that came before it, so it must be true. It's not. It's crazy. That's the most frustrating thing, when someone is meant to have this, people are meant to be the gatekeepers of this information, and they're meant to have the answers, and they're just wrong, and it's very frustrating.
The thing is, though, with the doctor title, it's quite a prestigious title to hold, but you could be a doctor in, I don't know, I'll pick something at random, something like religious studies, and then, portray yourself as the world's foremost expert in dinosaurs, for example.
You can get a PhD. You can get a PhD in basket weaving.
I don't know how a PhD or a doctorate in religion would prepare you for becoming an expert in paleontology and history. I don't get it. I really don't.
It's people going out of their field because they think, I've mastered mine, so I'll take a look at this, And I don't know whether it's not learning how to properly reference stuff or whatever. But it was good. Well, like when I did my degree, it was very strict on where you got your sources. You know, like if you did not get your sources from a reputable place, it doesn't matter what you say. You know, you need that was one. We learned that like I'm not going to say day one, but definitely in the first year. They were very strict on it. We had an entire class on how to reference correctly. So that doesn't exist in every course, you know, but it really should. It really needs to be taught more often.
Yeah, I think you're right with the Dunning-Kruger thing you were saying before. This person I was talking to a couple of days ago, when they made the claim that because the virus has RNA and not DNA, it meant PCR couldn't be used. Now you've explained that away, etc. And I said, why do you say that? And they copied and pasted a definition of DNA, a definition of RNA, about, you know, to highlight the differences between them. Sent it me, and said, "There you go, the different things." And that was it. Like, he thought that was a winning argument. I said, "How is that even relevant? You complete numbnut."
Hey, I'll give you one better. I had a discussion with someone on Twitter. I think it was yesterday, or the day before, where they firmly believed and could prove that drinking energy drink can send molecules to your liver that blocks messages from the spirit world. Now, when I started the question, like he started it with, "I bet that X, Y, and Z," and I said, "Oh, easy money. You know, I mean, you can't prove that. You made a positive claim. You're obviously not going to be able to prove it." And the response was, "Well, I could prove it to someone who's open-minded." And no, that's just not. Send me that link. I need it.
I don't know if you fancy having a whip round, or if Catz could give me $3,000 and Paul would give me $3,000, because I desperately want to be Dr. Blinder, and apparently it's $6,000. What a bargain!
How?
Yeah.
How?
And, you know, I will be Dr. Blinder or Dr. Creaky to my friends. But this was something I found out during the making of yesterday's video. So
that's crazy.
What I'm saying is that those 2 digits that come before your name can be come by through not the right.
They can, but most of the time when you hear it, I suppose you kind of want to think, "Oh wow, this person did a PhD. That's impressive." You know, it's difficult. It's not easy work, and particularly in a PhD in like, you know, anything like virology or any kind of science like that. That's a lot of work. That is like 10+ years. So when I see the D and or and the dot before someone's name, you know, inside I get excited, thinking this person must know what they're talking about. And it is a shame that I can't even trust that anymore.
I should just buy a doctorate in technology, because I'm so good at live streaming. That's what I'm saving up for. I'm saving up for a doctorate in technology. I'll be PhD Creaky Dr. Blinder.
Yeah, give it a go. Just don't mute yourself. You'll be all right.
Yeah, I'll do my best. I'm going to put some sellotape over my mute button so I can't mute myself and then forget to unmute myself. But the point, I know I'm acting the clown, but the point I'm trying to make is some of these people maybe, "Oh, look, this guy's Dr. Creaky Blinder. He's clearly an expert and we must believe and listen to everything he says." But they don't know, you know. I know that would be an extreme example, but the doctorate could be in, well, what did you say, basket weaving?
Yeah, you can get a master's in jam making over here.
No, jam.
Yeah, I mean,
people don't know that. They just see those 2 digits in front of your name, and you absolutely have to be right about everything you say.
Exactly, particularly if they sound confident, and that's a huge part of it. If you're confident and you have the kind of the digits for Dr. Dre, I don't know. I mean, he must be telling the truth. He's a doctor.
Exactly. This is the point I'm making. But in what, and is it? Yeah. I know the instances of it being, you know, disingenuous are probably very rare, but
and you almost sound like asking is like a problem. When you say, "Oh, doctor in what?" people are like, "Oh, why would you like?" You know, you don't trust him. That's like, Well,
Yeah.
no, based on what they say, I can't. Like we were saying earlier, like Dr. Kaufman and things like. Is it like he believed that the human heart doesn't pump blood? Like
That's Thomas Cowan. Yeah,
was that
but
Thomas Cowan?
yeah, it's ridiculous. But the two of them are brothers in arms. Really, they appear on each other's channels and they back each other up. So
Yeah, I saw it on your channel, Katz, and that was scary.
yeah, very, very odd. That was very, very. I mean, I don't. And he apparently was genuinely an emergency room doctor. Now he did put a message out saying that he was handing back his license, so he could no longer be able to prescribe prescriptions because he didn't want to take that path anymore.
Yeah.
I just wonder whether handing back his license, as he called it, was his choice. Like,
I want to point out what it I suppose what it used to be. So you know about the guy who found the link between vaccines and autism. I'm running a blank on his name, but I know he was a doctor, and his research was tested, proven to be false, and he lost his license. So like, I don't want to sound bad, but like in an instance like that, where such a massive piece of information is falsified or incorrectly done. I mean, people can make mistakes, but I mean, it was very obviously not true. Then I mean, there should be repercussions. I mean, there isn't going to be, because now you'll find people that will believe them, and then it's just a case of, well, agree to disagree. But there's no negative impact anymore, and that's a shame.
Yeah. There's got to be some way of keeping them in check and making them accountable, because the damage that missing, because with social media it spreads so fast, doesn't it? And they get almost like a celebrity status from it, don't they?
And again, you're going to get those like people as communities sticking together, and they retweet things, and then they'll start following you, and like you can kind of retweet anything after that, and they'll be like, oh, I remember this person said something interesting about X, Y, and Z. This must be true as well. And like you said, it spreads like wildfire. I mean, unfortunately, in a lot of instances, people prefer to hear these kind of crazy lies, and maybe it's just, I don't know, maybe they're more interesting than the truth. But you definitely need to, find a way to literally pick out the truth from all of this kind of hodgepodge of information. But no, something like this is good. I mean, I wouldn't talk about any other form of, like, I don't have like expertise in astrophysics or anything like that. So I mean, I wouldn't give any information on that, because like I learned PCR, I know how to do PCR, so I will explain that to people. And it's good having an outlet like this where you can kind of tell people the truth. So.
Well, that's what they differ, because you take your typical flat earther in the community at the minute, and they are experts on what happens at NASA. They are experts on thermodynamics. They are experts on optics. They are experts on seismic waves. And then the virus comes along. They're suddenly experts in virology.
Yeah.
They're experts. They know it. They know it all. They know it all because they've spent 5 minutes looking at something on the internet, and they've not understood, things people like you say. So they don't need to worry about what you say, because they didn't understand it. Like, I didn't understand that. Forget it.
They watch 6 or 7 YouTube videos, as you once put it, and there you go. That's enough.
Certainly, and I mean, I asked that reference was true. I was in a chat with somebody, and I actually asked them, how many YouTube videos did it take for you to watch before you started believing viruses didn't exist? Yeah, I thought they'd realise it was a joke.
I saw that, and I kind of it made me chuckle. I'm not going to lie. All I need is 6 or 7 YouTube videos, and I can make someone believe anything. That's awesome. Give me money. Watch my videos.
That was brilliant. What do you think, Creaky? Anything jumped up in the chat?
No, nothing. People are just having a pleasant conversation amongst themselves now. So do we want to take some questions for Paul from the side chat?
Yeah, just tag us in. So I think, and while people are putting those in there, I think it was a brilliant explanation, Paul. Really, really enjoyed listening to that. And I think anybody can be directed to your explanation there. And answer, and get the answers they're looking for if they are a little bit suspicious about PCR and what it is, etc. So, thank you so much for that. Have you got a channel or something that we should be advertising?
I do have a Twitter account that I use. I have a YouTube account as well, but I don't put up videos. I don't have the time. But I use Twitter a lot. I run by the name of Sentient Science on Twitter. So I follow you and you follow me on it, which is great. But I mean, yeah, that's pretty much where I would do a lot, because I don't know. I don't want to sound bad, but a lot of people on Twitter need to hear stuff like this,
I'll just type that in the chat now. What's your actual handle? What would it be? At what?
I'm doing it now, Kat. You've got the Mona Lisa pulling a funny face in your header, yeah?
That's it, yeah.
There we are, cool. I was on the ball for once, Kat.
Yeah, that's why you were a doctor and he is not.
Exactly.
We've got one here. I don't know if this is strictly in your field, but we'll go for it anyway. Discussing the mRNA vaccine. Some people think it's able to modify our DNA.
Okay, so the mRNA vaccine. First of all, one of the things that scares people about it is it's novel. There hasn't been an mRNA vaccine before, and that scares people, and I get that. But very briefly explain why it won't modify your DNA, as some people claim it will. The idea of the mRNA vaccine is that it has a code for the spike protein, the one we were talking about earlier for the antigen test. And what happens is this mRNA, this little messenger RNA, it's like a long code for a protein. This will enter the cell, and then what will happen is it will get the ribosomes in the cell, those little protein makers. They'll attach to the mRNA, and they will literally bang out a protein. I mean, it's a nucleic acid, or it's an amino acid sequence. That amino acid sequence will then fold into the protein of the spike protein, and there you go, it's in your cell. Obviously that scares people, but I want to point out that there is no other, it doesn't do anything else. It only makes the spike protein. It doesn't have all the other, think of it like a really modern kind of attenuated virus, which is what they used to do with vaccines. Now, in order for that to happen, it does not need to enter the genome in any way. The ribosomes, those little protein makers that I was saying, they literally sit in the cell. There's like millions of them, and they just sit in the actual plasma, the cytoplasm of the cell. So this mRNA vaccine doesn't need to go anywhere near your DNA. So it will not alter your DNA. There's no reason for it to do that. All it does is make the spike protein. Your body's immune system comes along and like, hey, what's this fella doing here? I better check this out. It comes along, sees something foreign, attacks it, and then decides, oh yeah, I got to remember this just in case he comes back. So then when the actual virus shows up, suddenly your immune system's like, I've seen you before, and then it attacks it and it stops it. It is essentially what a vaccine will do. In kind of, I suppose, all previous vaccines used to do, which was kind of give your immune system a little booster against fighting something, but it's done in a much more advanced way.
So, I mean, yeah, you'd need some sort of mechanism for what they're claiming to take that mRNA, reverse it back into DNA, then carry it into the nucleus and integrate it to the DNA of that cell it happens to be in. I know people might talk about retroviruses and look, they can do that, but you're not being injected with viruses, are you? Being injected with
you're being injected with mRNA. You're being injected with the little messenger that makes the spike protein, and that's it. And a huge part of this as well that people have an issue with. Oh, look, this is in your vaccine, and this ingredient is in your vaccine. I want to point out that most of these people don't know what quality control is. And in the instance where you're making a vaccine, you have what's called upstream processing and downstream processing. Now, in order to upstream process it, to make this mRNA, you need the cells, you need you need a medium, you need a lot of additional stuff. But then the mRNA is purified. It's purified so that all those other stuff is used to make the vaccine, but it's not in the vaccine. It's the equivalent of me saying you use an oven to make your cupcakes, therefore there's oven in your cupcakes. That's just not how it works.
Yeah.
I see that there was a claim there. can the mRNA cause autoimmune disease? So the mRNA vaccine, basically, I mean, like I said, all it does is create this spike protein. And you must remember that, I mean, this spike protein and the mRNA itself, it's not permanent. It doesn't just sit in your body and stay there forever till it's done its thing. It is for a limited time. So your body will fight off the spike proteins. Any mRNA that is not converted into the protein it won't survive in your body. mRNA, like I said before, is really, really fragile. So it's for a limited time. Your body has the ability to make this little antigen. So what is the mRNA vaccine? It's like I was saying, it's it's a messenger for a protein that your body doesn't make. Your body makes this protein, and look at this. It's the spike for coronavirus. There's nothing else there. Then your body eats that and remembers it. So when you actually get coronavirus, the whole thing, it can fight it off. It's simple. It's quite elegant, actually. I think it's really, really clever stuff.
Brilliant. Any other questions, Creaky, jump out at you?
I'm just looking through them now. A lot of them are asking a very similar thing. Some people are saying, is SARS-CoV the same as bird flu? I've lost that bloody question now.
That is actually an interesting, because it was, I believe, Trump was saying that it's the same as a flu, and many people were saying, well, because the symptoms are much like a flu, it's the same thing. I want to point out that saying that SARS-CoV-2 being the same as the flu is much like me saying that HIV is the same as Ebola. It's a totally different species. It's a different target. It does different things. I mean, there's circulatory problems for people that have had COVID, then have different responses. I believe there's something called the bradykinin storm. There's a whole host of other things that COVID does, including the kind of fill your lungs with jelly so that you can't breathe, and flu doesn't do that. What are limiting factors in vaccine production? That is a good question. I don't really know. I mean, I know that a huge part of it is that different companies are producing different vaccines. It's not one vaccine; it's many different ones. So obviously, what you have is a case where you might have 5 or 6 vaccines that all work for the same virus, and then you're going to have countries that are like, oh, I want that one. You're like, cherry pick. I want that one. I want that one. So you're not going to make one for the entire world, because not everyone's going to get it off you. So each one has to. They kind of have. They're not going to overproduce as well, because the vaccine doesn't stay very well if it's not properly stored. So they need to make sure that the rollout for the vaccine can keep up with their production.
I saw a tweet today. Now, obviously, I'm nowhere near as well organized as Catz, clearly. And the basic gist of the tweet was that, I'll try and find it after I've told you what it was. So they're basically saying, there's this mutation that they're talking about, particularly in Wales, and that the vaccines that have been released now will be ineffective because it's a mutated strain. Is that
right? Well, you're first of all going to have to actually find out what the mutation is. If this mutation doesn't affect the spike protein, then no, it will not have a different effect. The vaccine will work, because, like I said, the vaccine is only a piece of the protein, a piece of the virus. And the spike protein in particular, if that has the same target in the body as its previous mutation, then there's no reason why it wouldn't work. But right. People see this, there's a mutation in the virus. This virus is different. Yeah, but I mean, it's different in 0.00001% to the other one. So I mean, what are the chances that 0.00001% is in that protein? Probably pretty low. But again, it depends. I don't know the mutation, so you'd have to actually look at that.
Right, okay. I'll keep scrolling through and see if I can find it. But that was pretty much the gist of it anyway. Right, what else?
I see one from Dildo Baggins there, just asking about the speed that the virus was made. Yeah, because it was quite fast. Well, I was having anyone who's watched the Simon Dan podcast will see that Professor Jim Al-Khalili was on, and I don't think this was included in the podcast. We had a very brief chat off air, and by the way, that guy is exactly off camera, like he is on camera. The guy's a legend. And we were talking about the viruses and scientific method, and he gave such an articulate explanation to that answer about the scientific method and about why people have that question. I wish I could repeat. I'm not going to do it justice, but he did explain it to me, and now I can't remember what his answer was. But no, perfectly safe. What do you think, Paul, about the speed at which it was made?
Yeah, okay. So I want to point out actually two pieces of information on that point. I want to first of all mention that SARS-CoV-1 came out 17 years ago. And remember, the actual, like I said, I had a paper where where a team managed to isolate and use kind of a modified Rivers criteria to prove that SARS-CoV-1 does what it does, to prove that it is the causative agent of, SARS disease. And that means that since then they have had the genome for SARS. So they could have, I would imagine they were, like, as soon as it became clear that coronavirus like this could even come out, I would imagine a lot of the work was done previously on it. Now, I do want to point out as well that, like, this kind of global pandemic, it's a once in a century event. So it's not a case where only a certain amount of companies are going to be working on this. This was a mass effort. Every company, every biotech company, pretty much in the world, wanted to be the one to make this, to make this vaccine. So 100% of their effort was put into this and nothing else. So with that, you're going to get a much shorter time frame for when they actually, when things go to work and do things like that. I do also want to point out that there's going to be no time delays when it comes to, doing the clinical trials. What they do is they do all the clinical trials, only they do more of them in a shorter amount of time. So that means that they still pass all clinical trials. And after passing all those clinical trials, they still get approval. They still need to be approved. They still put the same amount of money into it. It's just because it's so needed, it was done faster. That's all. It wasn't done faster out of laziness or out of not doing the work. All the work was done, but it was all just kind of confined into one time frame. So I do want to point that out when people have a lot of problems or issues with, the vaccine came out too soon. And, like, I know a lot of new drug applications can take 15 years and, to get approval. We needed this. So we are going to get it quicker. And I also want to point out, because we were talking about, things on Twitter and stuff like that. And I know people specifically online that are not going to take the vaccine because there have been allergic reactions to it. Okay, so 3 healthcare workers managed to get a mild allergic reaction after the first 1.1 million were injected. So people were saying, I'm not going to get the vaccine because I have a 99% survival rate if I don't get it. So why would I bother? Well, you've got a 99% chance of not getting it, but a 1% chance of death if you get the virus. Or a 1 in a million chance that you'll get slightly ill and be in hospital overnight. I know which one I'd pick.
Yeah.
So yeah, that's my 2 cents on the vaccine. I mean, I know a lot of people have problems with it, but and it's new as well. But I mean, all the work's been done on it. It's been done quicker because it's been important.
The thing is, though, this is just something for anti-vaxxers to jump on, isn't it? And unfortunately, all they need to hear is that one person became ill, or God forbid, one person died, and then that's enough for them to declare that the whole thing is too dangerous for the general public. Just one person. Yeah.
If only they were as antivirus as they were anti-vaccine, there wouldn't be a problem.
Exactly.
And you take the vaccine, there's a chance you get slightly ill because you've got that protein in your body, and then you fight it off, and suddenly you're immune for whatever length of time it works for. I mean, you might not get a full immunity, but definitely enough, to last us for a while. Or you get the virus and really take your chances. Like 1% of people dying, but what, 5% of people seriously ill in critical condition. The chance that you go to hospital and you don't get a ventilator because they're all out, that's terrifying. You know, I picked the vaccine 100% over that.
Definitely. Well, I feel like I've learned loads tonight. It's been a massive, brilliant refresher for me on all that stuff. I've really enjoyed it. It's a shame that Berian didn't hang around in the chat, because I'm sure he'd have had some fantastic questions. But let's have a look.
You seem such an expert as well. I was hoping for a real, you know.
Is it Dr. Berian by any chance?
It could be. Unless he's taking up as well, Paul. Unless he's taking up as well.
Professor, I think, was.
Right. Yeah. That makes sense. That makes sense. That makes sense.
Well, there we go.
Here we go.
I know it appears as though I'm staring vacantly into space, but I'm just making sure I've not missed any questions that are completely aside from what you've already answered. And to be honest, I really don't think I have. So
no, I think we've covered.
No problem. I want to thank you guys again for having me on the channel. I'm a Patreon of the channel, and I do watch it, and it's really nice to be invited on. So, like, a million times, thank you so much.
I would love to have you back on. Love to have you back on. And if you ever fancy coming on and doing a debate, you know, we keep it civil here. We wouldn't have anyone coming screaming, shouting.
One thing I love. It's nice to actually. It's not like we don't need to scream, even if we can agree to disagree and have a civil conversation, and that's good. It's good, particularly to see that, especially when you got different opposing views. It's good to get all of that.
Well, I think, well, I'd love to have you back on. You've been brilliant, really clear explanations, dead articulate. And if anyone does encounter anybody on Twitter who makes these ridiculous claims, this will be an excellent video for them to come and listen to. And then, they can sit and question themselves and think, actually, do they really know the stuff as well as this man? Do they know the stuff as well as they think they do? Because I think the answer will be no. So there we go. But no, thank you so much for coming on. I really appreciate it.
Thank you for having me, guys. It's been a pleasure. Okay.
What do you think? I don't. Oh, hang on. Yeah. We'll say goodbye to you off. I'll say goodbye because I want to give you a virtual handshake.
Yeah.
Sure.
Very quickly, just thank you to Chris Shapley, Buddy Zap, Dildo Baggins, and Truth Nerd for the super chats tonight. I'm far too childish for this sort of highbrow conversation, but there we go. Catz, have you got anything you want to sign off with, or are we just out there?
Oh, no, I'm sorry.
You going down then, didn't you?
I was reading the chat.
Right, thank you, everybody. Thank you to Paul. And we will see you. We'll see you next time. Take care and goodbye.
Bye now.
Bye.